In this video, I want to talk a little bit about solving an equation that's already written in factored form. So far we've talked about factoring expressions, and now we're going to actually be dealing with equations. So typically in algebra, we solve equations by first setting them to 0 and then figuring out what values of y will make the equation equal to 0. Okay, so we have to do a little property first. So if we have a times b is equal to 0, then either a is equal to 0 or b is equal to 0. So at least one of them, they may both be 0, but at least one of them has to be equal to 0. Okay, so when we're given equations like the one we have here, 2y plus 3 times 4 plus y, we have to figure out all the different times that this could be equal to 0. Okay, so for this first one, we have this equation equal to 0. So the idea is we want to figure out which values of y would make this equal to 0. So we need one of these, or in this case, we're looking for both of them really, when they're equal to 0. So what we're going to do is we're going to set each of these individual terms equal to 0. So first, we're going to start by setting 2y plus 3 equal to 0. And then we're going to solve for y. So we'll take 3 away from both sides, and that's going to give us 2y is equal to negative 3. And now we can divide both sides by 2, and we get that y is equal to negative 3/2. Okay, so we know that if y is equal to negative 3/2, this term here is going to be equal to 0. And therefore, this whole expression is going to be equal to 0 because we'll have 0 times some other number. It doesn't really matter what happens when we plug y equals negative 3/2 in here because we know that this particular term is going to be equal to 0. And therefore, the whole thing is going to be equal to 0. Okay, but what about the other one, 4 plus y? We'll set this one equal to 0 now. And now we can solve for y. So if we take 4 away from both sides, we get that y is equal to negative 4. And once again, if we take y equals negative 4 and we plug it in here, this term is going to be equal to 0, and therefore the whole thing is going to be equal to 0. Okay, now let's look at this one. Here we have 5v minus 9 times 7 plus v is equal to 0. All right, so we set each of them individually equal to 0. So let's start with the first one. We have 5v minus 9 is equal to 0. Now we can add 9 to both sides, and we're going to get 5v is equal to 9. We can divide both sides by 5, and we get that v is equal to 9 over 5. Okay. So next, let's look at 7 plus v. We have 7 plus v is equal to 0. We can take 7 away from both sides, and we get that v is equal to negative 7. So what's happening with each of these is we're actually getting two solutions for all of these. So we look at the first one, we had a solution of y equals negative 3 over 2, y equals negative 4, and here we have v equals 9 over 5, and v equals negative 7. That's fine. These are both going to be valid solutions to this equation. You're not necessarily always going to have just one solution to the equation. So let's look at one more. Here we have 2w minus 3 times 7 minus w. Okay, so we'll look at the first one, 2w minus 3 is equal to 0. We can add 3 to both sides, and that's going to give us 2w is equal to 3. We can divide both sides by 2, and we get w is equal to 3/2. So that's one of the solutions. And then for the other one, we have 7 minus w is equal to 0. And for this one, it'd be easiest to just add w to the other side. Keep everything positive. So we'll have w is equal to 7. So again, these would both be considered valid solutions to this equation.